Today we are taking a look at the hyperbola, chapter 6, page 110. So let's first have a look. Our formula would always be y equals a over x plus q. And this is our standard form. So I always remember it as almost like a little x that is in different quadrants. Okay, so let's have a look. When we look at our formula, y equals a over x plus q, if a changes, it stretches the hyperbola. What does that mean? I will show you in the next picture. As y changes, it moves the graph up and down, and it also influences the asymptote. What is an asymptote? An asymptote is a line on the graph that the graph approaches but never touches. Okay, so let's have a look here. This is the influence of a. So as you can see, our first graph was y equals 1 over x. The bigger x gets, the further it moves away from the origin, and it's almost as if it becomes stretchier. Okay, so 5 over x, 3 over x, you can see the bigger it becomes, the further it moves away. This over here is when a is bigger than 0. Over here is when a is smaller than 0. Do you see that it's only moving to different quadrants? Bigger than 0, we have our graph in quadrant 1 and 3. Smaller than 0, we have it in 2 and 4. Okay. Now let's have a look at the influence of Q. So what does Q do? Q moves the graph up and down. So the first one we had was the black one over here. And that means x equals 0 was an asymptote. Y equals 0 is an asymptote. What does it mean? Our graph will constantly move towards the line, but it will never, ever, ever touch the line. That makes it an asymptote. Now, if Q changes, it moves see the blue lines go together, and the green ones go together, and the red ones goes together. If Q changes, it moves the graph either up or down. This then also influences the asymptote. Your asymptote would always be equal to what the value of Q is. For the asymptotes here, we see the x stays the same because it doesn't change the x, but it moves up and down on the y. So the y asymptote will change.